For this video, we'll be talking about some of the more common functions, also known as parent functions, which we'll be taking a look at throughout this unit in a variety of ways. But this video, we'll be talking about 6 of them, what exactly they look like graphically from an equation perspective, as well as in a table. And then we'll also be looking at the fundamental domain and range for those parent functions. So our first one that we're going to look at is the linear function, which in its most basic form is y equals x. And you can see I have the generic version of that sketched over to the right, or to the left rather. If we look at it from a table standpoint, we'll take a look at the 5 kind of central located points. So basically, since y equals x in this table, all of the x values are going to be the same as all of the y values. So when we're plotting, we're looking at -2, -2, -1, -1, and so on and so forth. Now, as far as domain and range are concerned, our graph has arrows going in both directions, left to right. So our domain is -infinity to +infinity, or all real numbers. And looking for the range, our y values also have arrows going down and then up. So it's going to share the same range of negative to +infinity. Next parent function is the quadratic. Our quadratic function in its most basic format is y equals x squared. In this case, when we plug in our x values, we're going to be subbing in the same x values as we did for the linear. So in this case, when we square -2, so -2 squared, putting it in parentheses, that negative squares out, so we're up at 4. And then if we go down the line here, -1 squared would be 1. 0 squared would be 0, and then they start to repeat, which gives us the shape we're looking at over on the left, the parabola. Now, the domain for this obviously goes forever left to right, because as it goes up, it goes out left and right, gets broader. But the range is a little bit different. It starts at the origin, so 0, and then it keeps going up when we're just looking at y equals x squared. Obviously, we know parabolas can go up and down, so we'll take a look at that later in the unit. Next 2 functions. First, we're going to look at a cubic function. So that's y equals x cubed. So in this case, for our table, we're going to plug in -2 and cube it. Well, 2 cubed is 8. In this case, does the negative stay or go? Because we're multiplying 3 times, it stays negative, so -8. -1 cubed, when we sub that in, we'll get -1. 0 cubed is 0, +1 cubed is 1, and +2 cubed is +8. So the cubic function kind of looks similar to our tangent curve, if you remember that back from Unit 3, but it starts over on the left and it increases as it crosses over the origin and up and to the right. So for domain, left to right, arrows pointing outwards, so negative to +infinity. And for the range, more obviously, it's going up and down forever, so also negative to +infinity. Letter D here, the rational function. We'll talk a lot more about this in Unit 6, but just to get some previewing of that, 1 over x is the most basic format of a rational function. So in this case, when we sub in our x values, we'll be plugging in 1 over -2, which is just -1/2. 1 over -1 is just -1. What happens when we plug in 0? Well, 1 over 0, think about it for a second. If you said undefined, you were correct. If you said 0 or 1, double check your thoughts there. When we divide by 0, that's an error for us. And graphically, looking over on the left here, the y-axis is completely untouched. We'll, again, talk more about this in Unit 6, but there's going to be a vertical asymptote, if you recall those, again, from tangent and cotangent in Unit 3. And then we move into the positive, so when we plug in +1, 1. When we plug in +2, we get +1/2. Now, domain and range get a little bit interesting on this one. So domain-wise, we are starting all the way to the left. We have an arrow over here, right, indicating -infinity. But because this y-axis is completely untouched, we're going to stop at 0 and put a parenthesis because obviously if it's not included, we don't want to use the square brackets. And then we're going to just basically jump over it. We're going to add another interval from 0 to positive infinity. And range-wise actually is the same thing because the arrow pointing downward means negative infinity. But then there's a horizontal asymptote because our x-axis also does not get touched. So we went from 0, we'll union, and pick up after 0 and continually up to infinity. Then our last two functions, we've got the square root function and the absolute value one. So square root is y equals square root of x. This one, you notice that the table is a little bit different because if I plug in negatives, 1, I'm not going to get an output because we can't put a negative into a square root. And 2, we have some not so pretty points in between the ones that I've chosen. So if we plug in 0, the square root of 0 is 0. If we plug in 1, square root of 1 is 1. Square root of 4 is 2. Square root of 3 is, or square root of 9 is 3. And square root of 16 is 4. So you can see I chose those points on purpose so we would get pretty points in our table. So that means domain-wise, we're starting at 0, and we continue to go up forever. Range-wise, we also, our y value starts at 0, and it's a little bit slower of a rise, but it will also go up forever. And then lastly, our absolute value, that's those vertical bars, so y equals absolute value of x. And it looks similar to our linear function. The difference is that on the negative end, we're going to get positive outputs, because when we take the absolute value, we're looking at the distance from 0, which is always positive. So domain, forever left and right. But the range can only go to 0 and up. Can't have anything in the negatives for the traditional parent function y equals absolute value of x. So at this point, when you're practicing finding domain and range, you should be able to look at these 6 parent functions and kind of work off of the original domain and range and make some edits based on what you're seeing.